Okay, so in today's lecture, we will learn about what a Wronskian is and how it can be used to check the linear independence of a given set of functions. So I will begin with choosing our set of functions, and let us say our functions are denoted by y's. So let us take n functions and let them all be functions of x. So we have n functions. We are calling each function by y. Subscript tells us the function which we are talking about, and x is our independent variable. Then Wronskian is determinant of a matrix which is constructed by using these functions and their derivatives. So if we have this set of functions, then its Wronskian will be determinant of a matrix. I said matrix which is constructed from the functions and their derivatives. The first row of this matrix will be the functions themselves. So we have n functions, we have n columns. The second row will be the first derivative of these functions. So we have first derivative, we have second derivative, and the first derivative of all the functions. Similarly, third row will be the second derivative of all the functions. And the last row will be the nth derivative of these functions. So now we have an n cross n matrix, and if we calculate the derivative of this matrix, then it will be called the Wronskian. And the property of this Wronskian is that if this Wronskian is equal to 0, it will imply that your functions are not linearly independent. So it will imply that the set of these functions are not linearly independent. And we will see how. So as a proof of it, let me assert that these functions are not linearly independent. So our assertion is that these yi's, where I goes from 1 to n, are not linearly independent. If this is true, then what it means? It means that if you write your linear combination and it equated to 0, it will look like Cn yn equal to 0. All the c's are the constants used for making the linear combination, and this expression will imply that there exist some ci's which are not equal to 0. So there are certain ci's which are non-zero, and this expression, but the value of the remaining ci's is such that this expression is equal to 0. If this is true, we can always use this condition in order to simplify our matrix and the determinant. So if I make a column transformation in W matrix, I make a column transformation. Your first column C, replace it with A1, column C1 plus A2, column C2 till AN, column CN. Make this column transformation, and what it will imply, it will lead to a determinant A1 y1 plus a2 an y2 plus a2 y2 prime plus so on plus an yn prime last a1 y1 n minus 1 a2 y2 n minus 1 plus an yn minus 1. This is your first column after the column transformation. The other columns remain as it is. Yn this. Now what you will do is, what we will do next is, we will use this condition here. If we use this condition here, our first matrix, our first column will become 0. So when we use this, it will mean that our first column becomes 0 all throughout. The other columns remain as it is. Yn prime and Yn n minus 1. So this first column equal to 0 means that the determinant will be equal to 0. So we saw that if we started by saying that all our functions are not linearly independent, and if we start with this assertion, we come down to the conclusion that for this particular condition, Wronskian should be equal to 0. So we know that if Wronskian is equal to 0, it would mean that the functions which are given to us are not linearly independent. And if Wronskian is not equal to 0, it will mean that the functions which are given to us are linearly independent. So let us take two examples. In one example, we will take our functions which are linearly independent and calculate its Wronskian. And in the second example, we will take our functions to be linearly dependent and then calculate the Wronskian. So let us take first example, example 1. In example 1, let us take sine of x and cos of x. So what is Wronskian? Here now y1 is our sine x and y2 is our cos x. So this is first row. Second row will be the first derivative of it. So first derivative of it and first derivative of cos. What it will be? It will be sine of x, cos of x, cos of x minus sin of x. So this is equal to minus sin square x minus cos square x, which is equal to minus 1. So it means, it implies that sine and cos are linearly independent. Let us take another example, example 2. And let it be 1 minus x is our first function, 1 plus x is the second function, and 1 minus 3x is the third function. Let's calculate the Wronskian. Wronskian will be 1 minus x, 1 plus x, 1 minus 3x. First derivative of the first two, it will be minus 1 plus 1 minus 3. Second derivative of the first two, it will be 0, 0, 0. So you know that this is equal to 0. It means that the given functions are linearly dependent. So this implies linearly dependent. And linear dependence means we can always express one function in terms of the other function. So by observation, it looks like that 1 minus 3x can be written as some product of 1 minus x plus some product of 1 plus x. Let us calculate what it is. We have a plus b. So this will imply, this will give us it will give us a is equal to 2 and b is equal to minus 1. This means that we can write our 1 minus 3x as 2 times 1 minus x and minus 1 times 1 plus x. So this is 2 minus 1, 1 and minus 2x minus x minus 3x.